Hello, welcome to SpitFireMods. This is our one of our new units we're selling right now, Mach 10, Mach 20, Mach 30 unit. This unit happens to be a Mach 20 with two front thermal readers. What we're going to show you right now is how to set up your thermocouples to read your temperatures. And what you should have with the unit is a stainless steel thermocouple. It's a wire encased, stainless steel encased wire with the thermocouple in the tip. This is going to be used for reading our board temperature, and since this is rigid, we're going to put this one on first. This goes on the right hand connection, and then we coil up a little bit of it to take out some of the slack, and we run it under our front bar. And I usually just use these magnetic bars here that come with the unit to keep it in place. And you can basically just lift that magnetic bar up and set it down onto the stainless steel. That'll keep it in place. And then you can bend your wire. This wire purpose is for measuring your bottom heat that's coming out of your bottom jet, so you can make sure you're not overheating the bottom of your board. And what you want to do is bend your tip so that it's basically hanging in the lower nozzle area. You want to keep it up a little bit so it's not like down in reading the temperature down inside the unit. What we're looking for is more of an actual temperature. As you can see, it's about a 1/4 inch down in there in the center of the nozzle. And what that'll do is that'll allow us to get a temperature reading off our lower nozzle during our profile, so that we know our board is getting the proper heat to the bottom of the board. This unit grafts both these connectors, so we're going to be able to watch that live while we're reflowing or reattaching a chip. Then you're going to take your main connector, which is your primary. It's a fine, thin wire, a little thicker than a hair, has a very tiny tip. So what you're going to want to do is run that around the outside of your other connector, and this is usually run down the right hand side, and it comes in, you know, to under the nozzle. So what you want to do is take your length from the nozzle to the side, and then your best bet for this one is to secure it right between these first two rails. And Captain tape or any aluminum tape or anything would be good for that. And we're just going to run a full wrap around the bar, and that holds that in place. So now we have a probe that's handy at our disposal here to be put under the chip and to monitor our actual chip temperature during our reflows. So that can also then be laid across the back, so while you're loading your board, you can just set it off to the side, put your board in place. This is actually set up for Xboxes, but I'll just set a board here so we can give you a little example. Of course, I've bent my probe already with the prongs, so we're going to take this and set our board on top here, just to give you an example of how it's put in. And then you would normally take this probe, and if it's a PS3, you would slide it under the heat spreader. If it's an Xbox or the chip's exposed, you would take the very tip of the probe and just butt it under the side, and then take a piece of Captain tape. While you're holding it in place, then you tape the wire in place. So now you can see our tip of our probe is just butted under the edge of the chip. And we're going to graph that temperature along with the bottom heat temperature, and then our top model will have a digital readout over on the left hand side, which actually comes under the board and actually touches the board. So we have board temperature, lower hot air temperature, and the actual chip temperature itself. The reason these are the primary concerns here is because your lower board temperature is going to be your highest setting. You're going to want the most heat on your lower part of the board, and what that does is that allows our chip to be reflowed from the top with very little abuse to the chip. And then our board sensor is going to sense our board temperature so that we know our board isn't getting excessive heat where we're going to damage other components on the board. And then our upper probe is going to actually monitor the chip, and once we get into our reflow range or our liquefaction range for leaded or unleaded, whatever we're using, whatever profile we have, we'll be able to sense that. We can run our duration we want in that zone, and then the unit can be powered down and cooled down. So it's very easy then to take your probe off and just to tape it off to the side. Your probes aren't in your way. You can lift your board up, take your board out of the way. The lower probe in the lower airstream is not really affected, so that doesn't really get touched very much. I kind of bent that a little long there, but really the best way to do it would be pull the length back. Once you have it clamped in there, pull the length back so it's right there, and then make some bends and actually have it laying right there so it's actually straight into the airstream rather than coiled all up in there, so you're getting a good reading. So your tip's shooting right into the airstream, it's below the board, and your other probe is handy, so next board you got, you just bring it in and do it all over again. So that's how we set up the probes on the system. We'll do another video for the left hand, the third thermocouple. That's actually gets a meter, and then you loosen up this nut here and you put a actual arm, a small rigid wire arm on there, which holds your thermocouple on a little bit of tension, so when you set your board down it's actually resting on it. Anyway, that's the new model we have this year. This is a modified Scottle unit. It's the HR360. We do a variety of modifications to it to give it accuracy, a good clean profile run, give it more monitoring points, so you're actually sensing more than just one location. The unit comes stock with one thermocouple connection. We have two where it actually graph two thermocouples as well as monitor the board temperature on our higher end units. And with that type of system, you're actually able to get a near 100% efficiency because you're protecting yourself from any damage to the board. And that's the big thing. 100% yield is only when you know you're not damaging the board, which a lot of units, the IR units, will end up damaging your board many times when you're doing repairs. So this is our big unit this year. It's a very advanced unit, and we'll be doing some other videos on programming it and running it, and you'll see that it's very capable of doing pretty much any board. It has a cooling system, so you put your board on cold after you flux it, and the board comes off cold. So it's a very rapid machine. It's capable of doing a reflow in 10 to 15 minutes, and it shaves a few minutes off most reflow systems. And thank you for joining us here. It's SpitFireMods. Thanks.